Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3, Section 9, BFC21403, Structure Analysis. Today we are going to present our group project. The group members, the first one, Nur Anis Amira binti Samsul Akmar, Nur Hidayah binti Azhar, Muhammad Zuhairi bin Muhammad Yusuf, Syahiran bin Syahrizal, and lastly, my name Aisyah Nushahira binti Abu Aris. My name is Aisyah Nushahira binti Abu Aris. Today I'm going to present the first slide is about introduction. Structural analysis use applied mechanics, material science, and applied mathematics to compute the dimension, internal forces, stresses, support reaction, acceleration, and stability of a structure. The determination of the effect of loads on physical structure and their component is known as structural analysis. While truss bridge are among the most traditional types of modern bridge. The basic type of truss bridge have simple design that allow 19th and early 20th century engineers to easily analyze them. And lastly, it is a bridge with a load-bearing superstructure made of truss. The second slide is objective. The first objective is to design and build the latest bridge with the maximum structural efficiency that can cause a specific aperture while meeting the standard provided in this ruler. Secondly, to assess the strength and weakness of the bridge that support the load. Thirdly, to learn about the bridge planning and progress as well as teamwork and group effort. To foster student creativity and critical thinking when developing buildings, to learn about the challenge we encounter while analyzing the structure and how we solve them, and lastly to gain a better understanding of the structure analysis subject.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anis Amira binti Samsul Akmar. Today I will present to you the problem statement, the model dimension, and also the determinacy of the structure. For the problem statement, a construction company is building a community plan that measures two ravine-separated rural communities. This study plans a simply supported railway bridge to connect these two places and analyze whether it can handle the users and also the train load cargo. Aesthetically pleasing bridge can attract tourists and also having a great scenic point for sunrise and also sunset. When tourists visit this area, it could also generate income that can be used for the people at the area. For the model dimension of this bridge, the overall length of the model is 10 meters. The clear span edges supporting the abutment is 8 meters. The overall width is 2 meters. The height is 3 meters. And the point load on bridge at each joint is negative 2,500 kN. The size of I-beam for all the members of the bridge is universal column UC 305 times 305 times 283 mm. In order to determine the determinacy of the bridge, we are using a simple equilibrium equation, which is a summation of member and reaction equals to two sets of joint. In our project, we have 38 members of the bridge, 21 joint of the bridge, and lastly 3 reaction, which is a summation of a pin and also a roller. So when we are using the equilibrium equation, when 38 plus 3 time equals to 2 times 21, which is 41 is less than 42, therefore this bridge is statically indeterminate by 1 degree. That is all from me. Thank you.
Assalamualaikum. My name is Muhammad Zuhairi bin Muhammad Yusuf, and I will present about deflection of the trusses. The method that we use is virtual work method. What is virtual work method? Virtual work method, also referred as the method of virtual force or unit load method, use the law of conservation of energy to obtain the deflection and slope at a point in structure. This method was developed in 1770 by John Bernoulli. To find the deflection, we use the equation of sum of n and L equal to E, which is the small case n equal to internal virtual normal force in the truss member caused by the external virtual unit load, and the n with uppercase is internal member force in the truss, member caused by the real load. L equal to length of member, A is cross-sectional area of the member, and E is modulus of elasticity. And then we must calculate all the internal forces that have been explained by previous presenter, which is the red one is compression and the blue one is tension. And then we calculate the real force. To calculate the real force, we put 1 unit load at F joint, and then we calculate the direction at the both of the support, and we get 0.5 and 0.5. After that, we calculate all the internal members force. After that, to find deflection, we got sum of N and L is equal to 111,956 kN per millimeter square. The area is 36,040 millimeter square. The modulus of elasticity is 200 kN per millimeter square, and the deflection for these trusses is 0.154 millimeter. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hidayah binti Azhar and my metric number is TF210010. So in this part, I would like to share with you the analysis in determining the internal forces and deflection of the truss using software which is LinPro. The software was used to analyze the proposed bridge. In the LinPro software, the truss is modeled as the Warren truss as shown in the figure below. We have used point load with the average cargo weight of a train, which is 2,500 kN. After entering the modulus of elasticity, cross-sectional area of steel, and point load on the joint, the deflection and the internal forces of the members were calculated after we ran the analysis. We can get the data from the tabulated static analysis result as shown in the appendices part at the end of the project report. As we can see in the figure shown on the slide, the maximum deflection of the truss is at joint 5 and 15, where the value is negative 0.015831 and negative 0.014212 respectively, while the minimum deflection is at joints 2 and 8, with the value is negative 0.001421, and at joints 12 and 18, with the value is negative 0.000121.
Assalamualaikum, my name is Shairan and I will present about method that we use to find internal forces of the trusses. The method that we use is alternative method. Alternative method is used to determine the internal axial force in trusses members. It operates by cutting through the entire truss at a single point and solving for the unknown axial force in the members that traverse the cut section using equilibrium equation. This method can be used to solve for 3 unknown member axial force at once. Next, we go to the calculation. For the calculation, we need to find moment by identify the point at moment C, and the direction that being applied is counterclockwise. Then, we use the moment formula, which is force time distance. So the answer that we got is 30,750 kN. For the equation Fy equal to 0, we sum up all the vertical force acting on an object in the y direction, and the answer that we get is 30,750 kN. That's all, thank you.
Next discussion. Our group is building a Warren truss bridge with dimension 100, 0 mm length, 3000 mm height, and 2000 mm wide. Direction on support and interval forces is shown by comparing the LinPro software data to the human calculation. As a result, the stronger the bridge, the lower the value of deflection and the more stable it becomes. The design of truss bridge can be varied, but the most important factor is to ensure that the base is sturdy enough to handle the maximum load. Our group decided on one of the simplest Truss bridge design while keeping the requirements of strength and stability in bearing such loads in mind. However, in the context of safety measure, the Warren truss are the form of old and outdated structure. It may create a cause of huge wastage if the design is not done in proper manner. A properly designed and built truss will distribute stresses throughout its structure along the bridge to safely support its own weight, the weight of vehicles crossing it, and winding loads. Lastly is the conclusion. We will be able to calculate ultimate load combination and learn more about the different size of beam girder used in simple bridge design. We also learn about the method engineers take when designing bridge, such as comprehending the situation, identifying probable bridge loads, calculating the greatest possible load, and calculating the type and amount of material required to resist the load. Bridges are well known for their importance in our daily life. They are a vital component of city and motorways connecting people. It is significant responsibility for an engineer to be prepared for any danger while constructing a building, bridge, or other structure. We must ensure that the design is appropriate, safe, inexpensive, and has its own aesthetic value so that it's appears more unique while providing excellent safety. That's all from us. Thank you.